All right, so let's go ahead and get started. My name is Adam Buckner, and this is live training from Unity Technologies. Here again on another Monday night, and tonight we're going to be looking at an intermediate, a sort of code-heavy kind of subject. We're going to look at events, sort of an introduction to using Unity actions and Unity events, and we're going to be creating a simple messaging system. And just to be clear, because a couple people were curious, this doesn't mean messaging like messaging between two characters, say, in an online game. This is sending event messages between game objects and components actually, in our games to more easily facilitate communication between our game objects and our components. So it's going to be relatively code heavy. We're going to spend a reasonable amount of time in mono-develop, and then hopefully we'll have an explanation for our enigmatic little yellow capsule guy that we have up there. So why are we talking about an event system? And why the heck would we need one? When we're working in our game, we make references between game objects and components. As a matter of fact, there's a lesson that you can look at in the live training archive for investigating communication between game objects and components. And one of the problems with doing it this way is that we need a hard reference between our components. So if you have a player game object and it needs to know where the camera is, we're going to drag a reference. We're going to create a hard reference. We're going to write, public game object, my game object, and then we'll drag that reference or transform or camera or whatever our component is. We're gonna make that reference, or maybe we'll use it in code. We'll do a get component. So we'll get our component off of that game object. The problem that you have with this particular way of grabbing all of your references is everybody needs to know who everybody else is. And as games become more complicated and as games become larger and have a bigger scope, then the references and the interdependability, or the dependence that you have between all of these objects becomes larger and larger and more complicated. So as you make changes, as you build more on your game, or you decide to make some changes in your game, you have to go back and make sure that you've found all of your references, that you've changed all of your references, and that everything is still working. So it becomes a large sort of maintenance problem. So one of the solutions that we have to this is we can use events, and we can trigger events to do actions. And we can have actions or functions that listen to these events and listen to these triggers. So what we're going to do is we're going to create a simple script that is an event manager. And that event manager is going to hold a series of events. It's going to hold references to these listening actions, to these functions that are going to be listening to these events, and we're going to look at a way that we can trigger them. So let's just go ahead and get quite started. Let's go ahead, and I've got some backups here in case we use it. I'm just closing those down. So let's write some scripts. Let's go ahead and create a new C# script, and let's just call this one Event Manager. And then let's go ahead and open up Event Manager in mono-develop. So I'm going to get rid of the sample code because we're not going to need update, and we're not going to need start, and we're not going to need any of that sort of rubbish that we've got. We're going to start from the beginning. We're going to add some new namespaces. How about that? We're going to be using Unity engine .events. So we need that to be able to get a hold of our events. And one of the main stays to this relatively simple example script, we also need system collections generic. There we go. So we're adding Unity engine events and system collections.generic because what we want is a generic dictionary. So we need the events to be able to use events, and we need that dictionary to be able to hold a reference to our event and the event itself. So this simply is the primary core of what we're going to be doing. Private dictionary, and the dictionary is going to be made up of a string and a Unity event. Only if I can learn to type Unity event. Crackers. Here we go. So, and then let's just call this our event dictionary. So that's it. That's the primary point. Zoom up front. Yes, thank you. Command plus. It's going to be big. That may be too big. We'll bring that back. That's the basis of what we're working with, which is a private dictionary that's holding a string and a Unity event. And what we're going to do is we are going to create methods inside this this class event manager that will accept new events and new listeners to come in. And if we create a new entry into this dictionary, so if there's no new entry into this dictionary, we'll create one. If there is an entry in this dictionary, then we'll go ahead and add to it. And then we also have to be able to unregister or unlisten to the events when we're done with them. So we have to create methods to take them away. So the very first thing I want to do is find a way that we can grab this script. So we're going to use this as the core, for our test. So all of our other components in our game need to be able to grab this event manager relatively easily. And we're going to do this in a slightly different way than we've seen before. I'm going to make a private static, so it's easy to grab, part of the class, event manager. So we're going to make a private, ooh, come back here. Let's do that again. Event manager, there we go. Private static event manager, and then we're going to call it instance. Now, we've seen this pattern before, where then we make sort of a singleton reference to it, and then we can go ahead and we can grab that singleton reference. But I'm not going to do that. I am going to do this in my getter. I'm going to do a get here. Oops, come back here. And this is partly because I want to look at a different way of doing things, and partly because I also want to do something when we go ahead and grab this first instance. So what we want to say, if we're looking for that event manager instance, we want to say is if there is no event manager. Oh, come on, give me the lowercase one, please. Oh, I haven't. Ah, that's because I didn't make it. Let's skip a whole line here. We have to make the instance of this. So there's our private static. Come on. Mr. Monodevelop and their code completion. It doesn't know what's going on, so it doesn't complete it right. So let me just delete that for a second and then write what we need. We need our private event manager. And then we'll call that our event manager. That's our instance of it. And then in our getter here, we'll go ahead and let me just write this all the way out. Do it again. So let's do that. Public again. Public static event manager. And then our instance. And here, when we get we want to say if we don't have our event manager, if we don't have that instance of event manager, and we still don't get the code completion, which annoys the heck out of me and makes me nervous. Private static event manager. I'm really doing great today. So private static event manager and our public static event manager instance. So if we don't have an event manager, then what we want to do here is say that our event manager equals find object of type of event manager. Cool, there we go. As, not surprising, event manager. So essentially what we're doing is when we've got our getter, so we look for it when we try to get the instance. If we don't have a reference to that instance, then we go ahead and we find it. Now, when we're done with that, there we go. If we don't have an event manager, then what we want to do here is give us a little warning and say debug, log error, quotes please, there needs to be one active event manager script on a game object in your scene. And so this is just a little bit of insurance, an insurance policy. It should never not be there because we're making our game. We should be smart enough to put it where it belongs, and make sure that we actually have an instance of this in our game. But if for some reason something is wrong, this is a mono behavior, so it does need to be attached to a game object to work. And this helps sort of clean up everything that happens in the script, which basically means when the scene is over, it's a mono behavior, it's attached to a game object, it will be cleaned up for us. So we don't have to worry about managing that sort of cleanup when this is done. So essentially, we're looking for an event manager. If we don't have one, we then find object of type. If there is no event manager, then we simply have forgotten to put one on in the scene. Now, if we get done with that, if we do have an event manager, so else, we want to take our event manager and we want to initialize it. Now we need to initialize our event manager at this point. We don't have a function for it yet, so let's go ahead and write it. So essentially what we want to do here, we want to initialize this. So let's go ahead and write our initialization function here. So void, let's just call this something simple like init. This is where we're going to load our dictionary. So we can get that instance using the getter, and if we don't have that event manager, then we find it. And that very first time, if we haven't found that event manager, if we don't have a list for it, we have to find it, and that also implies that we have not initialized it. So here's where we initialize it. It will only be initialized once, because from then on after, we will have an event manager. So what we want to say is if our event dictionary is the same as null, so that's 2 equals, then what we want to do is say our event dictionary is going to be equal to, not surprisingly, a new dictionary, which is a string and unity event. So essentially, we're just simply using this to initialize. And then in the event manager up here, let's go ahead and bring that back. And we will say event manager dot init. So this sets up the reference that we have. This will go ahead and find it. This means that we have an initialized dictionary. This gives us all the basis for getting our script up and running. Now, the next thing we're going to need to do is we need to be able to have our events register to this script, to put stuff into that dictionary. We also need to be able to have them stop. So we essentially need something that will start listening. We'll send some listeners and we'll start listening to an event, and we can stop listening. So let's create 2 new functions here. And they're going to be, I'm going to make this slightly smaller, that one. Let me know if that's too small. It's just it's getting a bit cramped. So we're going to need we need access from outside. So we're going to need a public. And then also, this one's going to be static as well. Public static void start listening. So void. So we now have start listening. And we're going to send it a string, which we will call event name. And we're going to send it a unity action, which is essentially a function pointer that we can then put a function into that will then act as the listener. So we're going to call this our listener. So that's the string and the unity action that will go into our dictionary. And in start listening, we need to create a new unity event. And this is because of the way that we're going to be looking at the dictionary. So let's create this new unity event. and let's just call it this event, and it'll be equal to null. Because when we are going to look at the dictionary, we want to make sure that there is a key value pair there. Because if there isn't a key value pair, we could be trying to shove something into nothing. And the ways that we can look for key value pairs is that we can do a contains key, but we're not going to do that in this case. So we're going to say is if, and then we're calling our instance, instance, dot event dictionary. And we're doing a lot of this long sort of verbose code here, so we don't have to do it in the scripts that access it. Then we're going to do this thing called try get value. So we're going to try to get this value. And we have our event name, which is going to be our key. And then we have an out keyword here, which is this event. So if the event exists, this event will get populated successfully with the reference that we need. So a quick note about try get value. Try get value is very similar to contains key, but it is at least as fast, if not faster, and at least as efficient, if not more efficient. And to quote from MSDN's entry into the try get value method, it says, this method combines the functionality of the contain key method and the item property. And if the key is not found, then the value parameter gets the appropriate default value for the value type. For example, 0 for integer types, false for Boolean types, and null for reference types. And then it says, use the try get value method if your code frequently attempts to access keys that are not necessarily in the dictionary. Using this method is more efficient than catching the key not found exception thrown by the item property. Just in case you haven't seen it. So for more information on try get value, go ahead and take a look at MSDN or start trawling Stack Overflow for more information on it. So we have this attempt at finding out if we have an entry into our current dictionary. And so if the try get value is successful, then we want to say this event, and we want to add listener. So the listener we want to add with add listener is, of course, the Unity action that we have just sent in called listener. Now, the very first time we do this, if we are just creating a new event that we want to listen to, there is going to be no entry into our dictionary. Our dictionary is going to be empty, completely empty, or it's going to have no key value pair for what we're looking for. So, else. So, and that should be on the next line. How about that? Something like that. This event is going to be equal to a new Unity event. And then we'll take this event that we've just created and add our listener to it. And that'll be the same thing. That'll be add listener, the listener. And then our instance dot event dictionary dot add our event name and our event, this event. So then what we've done essentially, if this is pretty obvious, is that we look at the dictionary, we see if we already have a key value pair for what we're trying to add to. If so, we add to it. If not, then we create a new Unity event, we add the listener to it, and then we push that to the dictionary as the very first entry. So that's our start listening. And here is our stop listening. So we again want to make this easy and accessible to our script. So that's public static, void, and then stop listening. And what are we going to put in as our parameter list? It's the same thing. So when we stop listening, we are also going to have a string, which is going to be our event name. And we are going to have a Unity action, and it's going to be our listener. So to unregister, if we've destroyed the event manager, that's what this is for. This is a little bit of a catch. So if we've destroyed or not found our event manager, so if it equals null at this stage, we want to make sure that we don't get any null reference exceptions, so we're just going to return. So if we are trying to stop listening and due to the order of cleanup or some other issue, we have removed the dictionary completely, we don't want to have some problems. So let's just go ahead and put in a trap where if the event manager is null, we just return from here. And then we do our Unity event, and it's going to be this event. And it's going to be equal to null. And then again, our get try value. So it's going to be if instance dot event dictionary dot try get value, our event name, and out this event. Okay, 2 of those. Oh, that's this event. This event. So when we're trying to unregister, if it exists, then we just simply want to say this event dot remove listener and the listener that we have a reference to. Okay, so we've added our that we can find from any other component, any other script that starts the listening, that ends the listening, and then we finally need something that's going to trigger the event. And so again, another public, let's come down here and give some space. I'm going to go ahead and just give some space down here. Let's see if we can fool mono development to coming up so we're not dragging along the bottom. Public. Static. Void. Trigger event. And this is how we will trigger our event. And again, we're taking in a string as our event name. So we're going to be triggering via our name. And simply, again, we're going to use our Unity event because we need to have this event. And it's going to be equal to null. And then again, our try get value if our instance dot event dictionary dot try get value, our event name, and then out this event. We will simply this event dot invoke. So we will simply invoke the event, and the event will then call all of the functions that are on those listeners that are listening for the event. So this is our event manager. Relatively simple. So new namespaces at the top. We create a single dictionary. We make an instance of it that's static. We then have a getter for the instance that we call instance. In the get, we say, if we don't have the event manager, we find it. If we still haven't found it after doing a find object of type, then we have an error. And if not, if we found it, then let's initialize it. And then if our dictionary is null, then let's go ahead and create that new dictionary. So then at start listening, we take an event and an action, add the listener to the event and stick it into the dictionary, or we create a new entry. During stop listening, we find the entry if it exists, and we remove it. And during the trigger event, we go to that entry in the key value pair, and then we simply invoke the event. All right, so that's one script down the drain. Let's go ahead and take a look at chat. Looks like Matt has you guys relatively relatively under control. Am I missing a return value to get? I am. Oh. Put that where it belongs, in the get. If event manager. Under the if. Pow. There we go. You're saying something about line 16. 16. If event manager. If not event manager. Manger. Fantastic. There we go. Thank you. I would have found it when I hit save. So speaking of which, let's go ahead and hit save and let's see if it compiles. Oh, look at that. No errors, thanks to you guys. I would have found that error when I saved and came over to the event manager. So now let's run some very simple tests. Let's just write a little test event manager we can stick on an object. And let's create another C# script. And let's just call this something like test1. And in test1, we're going to write a very, very simple thing that's going to just write to our console. We'll do something slightly more amusing in a little bit. Let's add using Unity Engine .events. And then in the class, let's go ahead and write private Unity action. And then let's just call it some listener. Some listener. Let's give it a name. And then where we want to do this, where we want to listen and unlisten for our events is in onEnable. And onDisable. And there's some very important reasons for wanting to do this. The way that objects are referenced and the way that objects are cleaned up, that if you don't unregister this connection, if you don't unregister the listener, even if you destroy the object, there's going to be a reference that's going to still be there, even if it's not, even if the game object itself that's being referenced isn't viable and it won't get cleaned up. So this system has a potential for memory leaks if you don't manage it correctly. So you want to listen in onEnable and you want to stop listening on onDisable. You don't want to do this in a wake and start if you're not ever clean it up. There are some good reasons for not wanting to do this in, say, onDestroy. That's also not an impossible place to put it, but you definitely want to make sure that when you are listening, you start listening and you stop listening, that you do both, and that you stop listening before you disable or destroy the game object. So first thing we want to do is sort of set up what this listener is. So in void awake, we want to say that some listener is equal to a new Unity action. And that Unity action has got to be some function. So we need to create a function. So let's just put down here the function that we're going to call void some function. And that function is just going to write to our debug.log and just say some function was called. And we can set up our Unity action by using some function. Now there is another way that we can do this, and we'll see this in the next script, but I just want to give this a quick idea of how we would do this, somewhat the more official way, but there are some shortcuts that we can do. So we can create that Unity action, we can populate that Unity action with a function, and then in onEnable, we can say to our event manager dot start listening, because that is a static function, and in the static function we get all of the busy work that we need to do out of the way. So remember, if we look at that start listening, we have our instance, we have our event dictionary, we have all of this buried inside start listening. So all we need to do is call the static class and call that static method, and then send it a name of our choice, like test, and then the listener, in this case some listener. Now we want to do the same thing in onDisable, except we want to stop listening. So let's save this and let's come back to Unity. And it compiles. Fantastic. I didn't even need your help that time. Woot! So let's create some game objects. Let's create a new empty game object. Let's make sure it's at origin just for the heck of it. And let's call this new empty game object our event manager. And then we'll put our event manager script on it. And then let's create another new empty game object. Again, let's, for no real reason, it doesn't affect performance or anything like that for this. Let's create one and just call it our game tester. And we will put our test script on it. Now, this is, come on. This is all well and good, but we're missing one step. We need something to call that trigger. So let's create a last C# script we're going to do for the simple example. And what shall we call it? Event trigger test. How about trigger test? Event trigger test. Something we know what it is. Event trigger test. Let's file that away in our scripts folder. And then go ahead and open that up. What? Oh, on disable. Yep. Sorry. So let's just look for our, actually we can do that in update. Let's just keep, let's keep the update that we've got here. And then, so if input dot get key down, what shall we make it? Just Q. So if we have our get key down as Q, top of the keyboard, then we want to say our event manager dot trigger event, and the event we want to trigger is test. So now we have all three parts that we need to get this system to work. We've got the event manager that's going to hold our dictionary of all of the events and listeners. We have our script that is trying to work within our game, and it's going to listen and stop listening and have a function to call. And then we have the trigger of the event. Something is going to trigger that event in our game. In this case, we're going to use this as the get key down. So let's go ahead and see this in action. We also have to put the trigger test on our game tester. This is going to be a miraculously wonderful, fantastic, let's save our scene as main. And let's save this in our assets. Scenes folder. We hit play, and then we hit Q. Some function was called way down here in the corner. Wasn't that a thrill? Okay, so let's try to do something that's a little bit more interesting than just that. So, I mean, we've seen that the function has been called by hitting our trigger, but not a thrilling example. So let's create our little guy that we're going to do something to. So let's go ahead and create our cylinder. Not a cylinder, we want a capsule. They're a little bit better. Let's create 3D object capsule. And then let's reset this guy to origin. And frame selected on him. And I've got some material set up and ready to go, like yellow. And let's go ahead and call him our minion. It's going to be our minion. And in our minion, let's create another 3D object. Let's create a cube. And our cube, our little cube is going to be blue. And this is going to turn out to be our visor. So there's our little minion guy. Some magic numbers. Let's go ahead and move that visor cube on the y-axis up to about halfway. Let's shrink it down a bit. Let's move this so we can see it. And then let's scale it to 0.95 so it's a little bit thinner. And then 0.25 so it's nice and thin that way. And then 0.5. Boom. So there's our little guy. And that is, in the end, just a cube that's been scaled to make it a little wiser. If you don't like it, we can push it back a little bit and give him a little bigger nose, maybe. 4.7. How about 4.1? There we go. Nice big nose. So there's our little guy. So that's going to be our minion. And then we also need to grab some stuff I have pre-written down here. I've got 2 scripts I've pre-written, which I'll quickly go through. They're in a folder called Web Player Templates, so they will not compile. So let's go ahead and bring these guys into our scripts. And then take a look at Self-Destruct. And Self-Destruct is relatively simple. I've got a private float called shake, which will shake our little guy. I have a private audio source, which will be look for the audio source. We'll grab the audio source. And in this, we do the same thing. We grab our event manager and we start listening for a destroy. So we want a destroy event. And then the event manager on disable, we stop listening. And then when our destroy is called, one of the things I'd like to note is that, sorry, that was a bit of a test I was working on. Take a look at Event Manager Stop Listening Destroy as well, because we want to make sure that we are absolutely sure we have removed this from the listener. So if we haven't disabled yet, we still want to go ahead and remove that. So now, because of our try get values, we can go ahead and remove it too many times, because that will be trapped by the try get value. So if value isn't there because we've already removed it, we can actually try to remove it in destroy and on disable. And then with destroy now, we've got some fun bits of animation and instantiating an explosion. But the main things that we're worried about or interested in is this chunk, which is essentially the same thing: on enable, on disable, and the function that we call, which is destroy. The simplification that we have here is, notice, compared to our test event, we are omitting all of this. The creating the private Unity action and then populating it in awake, because we can simply send the function name as the Unity action. So let's bring that back. So the other script that we have is spawner. And so if we're going to ignore spawn and we're going to ignore get position, the main thing here, again, is we have a Unity action called spawn listener. And this one, again, I've done the sort of the old school longhand method. In awake, we've used our new Unity action called spawn. And then in on enable and on disable, we create that entry for spawn, that spawn listener, and for unlistening, for stop listening. Now remember what I was saying before, those are good to know that you can do this, but you don't need to do it this way. You can simply use the function itself. Now, we can look at this in Q&A if you're interested, but essentially spawn sets these guys onto the game board and then checks to make sure that there's no collision. So let's go ahead, and we've got our spawner. We want to put our self-destruct onto our minion. And we want to put our spawner onto a game object called spawner. So let's create a new empty game object, and let's call this our spawner. And in our spawner, let's put the spawn script on it. And then we can do things like set how many we want to create. Let's say make 10 at a time. And then this is how big of a circle we will put the spawn unit, we will spawn the characters in. So let's just say it's going to be a 25 unit circle. And our minion offset, which is how far apart they should be, let's just write 0.75. And then our minion, let's go ahead and create a prefab out of our minion. And I'll show you that script when we're done. Like I said, I just want to make sure we get done before I describe everything. Get rid of our minion. Now, in our trigger script, our test trigger event, we need 2 more entries. So let's put them somewhere else. So if input.get key down, let's say O. We want our event manager, trigger event, and that we need to trigger is spawn. I'll have to double check the spelling if that was capital S. And then we want to say if our input is get key down, something next to it like P. We're going to take our event manager dot trigger event destroy, I believe. We'll quickly look because I actually can't remember. So what did we call these guys? Self-destruct was was destroy. So let's just copy and paste that just to be sure. So our event trigger is destroy, and our spawner is spawn with capital S. Good, got it right. So we save that, and these can do multiple things as well, which we'll talk about in a second. So let's come back to Unity. Let's create a nice background for these guys. So let's create a plane. Oops, 3D object plane. Let's make it a little bit bigger. I don't know, 5 by 5. And then let's give it some color. Also, I want to check my minion. My minion should be up, because when we instantiate him, we can just show you in the scene what I mean, is he's now going to be buried in the plane. So let's take our minion and lift him up by a unit. So when he's instantiated on the plane. There we go. Minion-y guy. Let's back out a little bit. And then let's also take our camera and back him out a little bit. Game object, onto view. Oh, that plane's not big enough. Let's make it bigger. 10. Now let's make sure that this works. Giant mystery. That's what I get for completely disassembling my game at the last minute. Pre-flight checks. Explosion. We need our minion needs an explosion. So let's grab our minion. Let's add our explosion. Oops. Self-destruct script. There. Ha! Dang. Let me double check what I've done. So it's not timing out placing the minion. Let's go to spawner, minion offset, spawn count. Rats! I should have just left this one up. I wanted to show you guys building it. Give me 2 seconds while I actually look at the script rather than running full tilt and trying to figure this out of memory. So my spawner. So why don't we talk about how this spawner works? Just because I need to read it. So we grab our spawn. So in the spawn, which is called by our event, we have a spawn count and we go through a for loop, and that for loop will try to spawn each and every one, and so it's going to get spawn position. So it's going to say the spawn position is the get spawn position. This is sort of the clever part of this this script, get spawn position here, where create a new empty vector 3. And then because we're going to try to place these, we want a start time. We want to limit how many times we go through this spawn. And then also, again, we have a test that is false. So we give it a while loop. And if we're not careful, our while loop will just go on infinitely. So we have a random inside unit circle times our spawn size. And so if we want to spawn within 10 units, our spawner has a spawn size of 25. So we can make that bigger, 50, but I don't think that's the issue because that gives us a spawn size of 50 units. Yeah, this is a bit of vamping. You're learning about the script and I'm reminding myself what I've done wrong. And so our spawn position is a random vector 3 from our spawn position raw x our minion offset. Oh, our minion offset is off the ground. That may have been it. A minion offset is 1. Okay. I thought that minion offset was how far apart from each other it is. It's not. It's how far off the ground. So what we're doing is, you'll see in a second, is that I test. My test is the opposite of physics check sphere from the spawn position by 0.75, so less than a unit, since that's the radius, and it's the equivalent of, if we looked at our minion, let me put our minion back, and let's frame select it on our minion. So I'm doing a sphere check, which is very similar to what you're doing with say a trigger collider, and so the sphere has a radius. There we go. That's 0.75 radius. So what I'm doing with that line is I am doing the equivalent of a check with a trigger collider that's that sized. So you can see, looking down at the top, I won't be bumped up next to, let's move that gizmo. I won't be bumped up next to another minion. I'll have a little bit of space around me, but I've decided not to do it with a trigger collider. Let's remove that I'm going to do it in code with the check sphere. And then there's the test. If real-time since startup has been a long time, we time out placing the minion. We return nothing. And there's the spawn position. So, and then up here, you can see that if the spawn position isn't vector 3.0, then we instantiate our minion with a random rotation. So this is so that we can fill up our spawn area without bumping into each other and having no overlapping minions. So there we go. So now that I've done that, and I've got the right size on him, our spawner has an offset of 1, so we're up off the ground by 1. That's the equivalent of us lifting up the minion by 1. We have our minion, we've got our spawn size, we have our spawn count. Let's hit play, and then with our trigger, I hit the O key. There we go. Minions! Yay, but I think that's going to be a bit too big, that circle. Let's make it more like 15. So it's sort of concentrated at the middle of this bit. So let's hit our O key, and we can see that every time I hit the O key, I'm creating new minions. So this is an event. So this event, I hit the O key, and the event triggers the spawn, and the spawn goes through it. But the other thing, remember, what we have is the P key, which, if we look at here, our P key will call destroy, and destroy will call this self-destruct, and this self-destruct has been registered from every single one of these guys. So it looks something like this, and it breaks because I haven't put an audio source on it. Minion gets an audio source. No, Minion actually gets an audio clip, because just dragging the audio clip will give us our audio source. There's our audio source, and we do not want to play on awake. And then let's cut the volume down to about 0.5. If this is too loud, we'll change it again. So let's try this one more time. O will give us our little guys, and P will blow them up. Now, because this is an event trigger, we can keep toggling back and forth. And as much as we said hit O, then it's going to create them. And we can create as many as we want. When we hit P, it'll blow them all up. The explosion is from Space Shooter. Straight out from Space Shooter, snagged. The sound effects, which I'm presuming you guys are hearing, are actually me earlier today and the microphone. So, so the whole point of this whole thing is that you can trigger events here. I mean, I am using my keypad for this, but I mean, the sort of inspiration for this was Lemmings, which is there's a certain point where an event happens in Lemmings, and all of the lemmings blow up. At this point, if you really had to have a reference to each one of these, and you can spawn as many as you want. You could imagine trying to write the code. We've just spawned 10 minions. And there is another thing. No sound effects. Oh, bother. Let's try that one. And there is another thing. No sound effects. So back to what I was saying, is that you have this event that happens, and this event needs to call the destruction on so many of the these items. Sorry, I didn't realize that I had turned off the game audio when I did that, before I did that. So if you have the if you need to destroy all of these from an event, the best way to do it is to use events. And that's what they're for. So this is hopefully will give you some ideas of things that you can do, whether it's opening and closing multiple windows. Imagine if you've got a game that has multiple windows that can be opened up from different things. You click on a chest, it needs to open your inventory window and your loot window and some other things. But to decouple all of this, being able to do it with events so you can register on to a listener and just say, hey, I'm here. Just tell me when this event happens, and then I'll call this action. I will do this action when the event happens. Just seems to be it's a heck of a lot easier. So anyway, and then also what you can do with that system I set up, and don't forget all of these will be posted, is you see we can fill up that radius that we've set, and it won't get any larger. It gets a bit slow because it's a bit randomly pushing, trying to find those spots, and then you can go ahead and blow them all up. When it does, it's going to be very, very slow because I'm running Twitch and I'm saving different things. And it's going to try to fill all of these with minions. And so it's testing each and every random spot. So it gets a little bit slow as it times out. But I think that's it. So yes, let's go ahead and... let's go ahead and ask Q&As. And first one is Dazoe asks, why not just use normal C# delegates and events? That's a very good question. You can, but the advantage that you have of doing this is the Unity actions and Unity events also tie into the UI system. If you want to stay sort of in that Unity paradigm, and say you need to have Unity actions or Unity events and you need to have a built-in UI for them, you can do that because you can add those directly. And we looked at that. Take a look at the making a modal window episodes, which we have 2, and we have a 3rd one coming up. And you can see how it works with the UI system and how you can build that in as part of the inspector by having those elements. So yes, essentially they are very similar and they are based directly on C# built-in events, but there are certain things that is useful to do inside the Unity paradigm and having Unity actions and Unity events rather than using just C# delegates. Chris Yarb asks, this Unity event system slower than C# delegates or events? The use of strings as parameters is seems prone to user error. Yeah, you can do anything else you want to when you're making your dictionary. There are other ways that you can make this dictionary. I'm just being very simple for explanatory reasons. So I'm just going ahead and using a string as my key value pair. But ultimately, whatever your key is, you can use whatever you want to for your key rather than a string. This is partly to see about how to make a simple messaging system and also an introduction to events and delegates in general, and specifically Unity events and Unity actions. And I'm realizing I missed a trick by not having a spawn sound when these guys appeared. Turn that down. So if you have any questions, go ahead and throw them in. I've ignored them up to this point, so all questions are new and fair game. As I've turned that down, we'll see if that's any better. So, watch your headphones again. I'm going to see if this is I've turned them way down now. I'm going to put on my speakers again. It's not that bad. Anyway, enough frivolity. Yeah, I'll add those sounds up as well. And it's literally me screeching and then doing some stuff on, Audacity, and then, sticking my finger in my mouth and going. So you've heard the sound effect. Since I'm new to this concept, is it possible to use events in combat as damage-dealing receiving methods, like swing a sword and hit something, and all the calculations are mediated using events instead of using different approaches? Or is it a bad idea? You can do that. I'm trying to think if that is the best way to do it. I think one of the problems that you'd run into, I'm just thinking off the top of my head, which is it's a little bit like using broadcast message or send message. You need to know who wants to receive this information. And I suppose that you could register it with listening. I haven't done any cross-comparison as to whether that's the most efficient way of doing things. I was sort of exploring this for a way of handling things like opening and closing windows from different places. In this case, if you're spawning things, you might want to have an event. I mean, I was sort of thinking more the other way around, where, like if you're in the middle of a quest, and one of the quests is to turn in 10 goat's livers, and then often you notice that in some games that when the 10 goat's livers have been delivered, then the goats are no longer targets. And that's one way to deal with it, is that they all register for the event, and when the quest is over, it sends out an event, this quest is over, and they all turn off because they were registered to that event. So any situation where you can think of where you want to register one or more items to a generic event, I suppose it would work. I'm sort of wondering is that each time you hit somebody or each time you do damage, it's a little bit different every time you do it. Depends what you're hitting with. I'd have to think about that. It might be worth opening a topic of conversation in the game design section of the forum, which I wish people would use more often. Chris Yarb just says, how could you show an example of how to register and call events without using strings as a parameter? Well, you can use anything that you want to as a parameter. I mean, it's a key value pair. Hash values. There's a reasonably good description of how to do that in the somewhat stale Stealth, where you can convert things into values. I can't think of a sort of an easy suggestion off the top of my head, but it takes any value. Just you want to find a value that you think is less prone to errors. You can also save them as string variables, which will help with auto-completion. But I mean, it works within this script. It doesn't work so well within other ones. You can say private string. And then you can use spawn, and then you get code complete, so that you aren't making. So you'll know if you haven't made whether you've made a mistake or not. Probably want to spawn key or something like that. I mean, just a suggestion. Simon Darkside, are you suggesting how you can add multiple things to? I mean, we could do this also with. Where's our test? I mean, you could do this as well. Event manager dot start listening spawn some other function. Event manager dot start listening destroy some third function. I haven't written these yet, just for example purposes. And the same with stop, except we want to stop listening, and then we want to then void some other function. And then another debug.log. Some other function was called. And then the same thing with that third one. And now you can see what we've done is we're registering both some other function and some third function to the same thing, to the same event that we did for spawn and destroy. So these are all additional listers to existing functions. So let's save this in event trigger test. Let's do this. If input.getKeyDown x event manager dot trigger event. I'm going to trigger event that doesn't exist. Junk. Oh, let's be proper. Let's put in our parentheses. So now let's come back to Unity. What have I done wrong? Oh, that's where I made the mistake. Right. So now I can create my minions with my O key, and you can see that it's also calling, let's uncollapse these. You can see that every time I do that, it's also triggering the debug log. And yeah, watch your ears. And then when I pop them, you can see that it was calling that third function. But I can call the X button and nothing happens, because there's no error with trying to trigger, with this system, there's no error with trying to trigger something that doesn't have a listener. It just gets absorbed. Cool. Any more last questions before I wrap it up as well? All right, I'm going to go off mic, and I will stay in the chat for a little while, and then I'll talk to you guys later.